Hey everybody, it's Monty, SPV Math, Algebra 2, and this week's expectations will be, first of all, don't forget, in our Algebra 2B SPV with Monty Teams channel, we post the weekly expectation. This video I'm making will be posted here. If you ever fall behind and you want to see problems from the previous week, just click on the stream channel at the top and you'll see them. Week 20, the first expectation, second expectation, a couple weeks ago, this week, and next week. Each week I'll be doing some of those problems. Okay, so that's item 1. Don't forget there's join links here, plus you can email and call. So let's get started. We want to find the internet. Once we find the internet, we want to go find Clever. There we go. We find Clever. Once we log into Clever, we're going to get to our Blackboard class. When you find your Blackboard class, and this one will be Algebra 2B, boom. In the announcements, you can see this video. I will post the announcements here in the video. The Math Excel for School link works here. The Math Excel link works here. If it comes to a calculator, you can reach out or you can watch how I do the calculator activities in the video. Okay? Alright, so now always keep an eye out for Sunday night's email. And this week, we just want to move forward. 1 lesson a week, 2 lessons a week, depending on your skill level. Never have to finish the entire assignment, depending on how much time you have and how long the problems are. All right? Now, I did notice some of you like Mathia. If Mathia wasn't your thing, just forget this part of the video. If Mathia is your thing, and it made sense to you, like it does for some, that can be a way for you to demonstrate understanding. You don't have to do Math Excel. Mathia works. And I'll finish this video with a couple of problems on Mathia. Alright? Okay, so let's get started. I'm going to click on Math Excel. Boom. When you click on Math Excel, go ahead and get logged in. And I am in Algebra 2. Okay? So, a couple weeks ago, we started the idea of the square root function. Last week, we did some of the problems on the quiz and the cube root function. We're getting ready for spring break. I would like to do a problem off of transformation, and a problem off of solving, a problem off of review. I'm going to do 3 problems. When we come back from spring break, we're going to move on. Okay, we're going to go into exponential models, and I'm going to mail you a cheat sheet for exponents and logarithms, because that's what we'll work on for a couple weeks after spring break. All right, let's get started here. So, transformations of a radical function. Question 1. Rewrite the function so it's easy to graph the transformation from its parent function. Describe the graph. Well, the first thing is we got to factor. You guys remember how to factor? Okay, been a weird year. You may not. Let's click on Question Help and view an example. Okay. Now in this case, we've got 49, 98. They factored out the 49. 49 times x is 49x. 49 times the 2 is 98. So this x minus 2 shows horizontal shift, and this one's going to be, because it's negative, it's to the right. Now the square root of 49 can be factored out, 7. So now we shifted it to the right 2 units, and then we stretched it by a factor of 7. All right? Okay, so we rewrite it like such, and this describes exactly what we're talking about. From the parent function, it went to the left, it got a stretch, did not go up and down. That's it. Okay, so let's grab our whiteboard and clear our canvas. How come my head's always in the way? y equals square root of 16x minus 48. They want you to see that there is a common factor of 16. We could factor out the 16, leaving x minus 3. 16 times x is 16x, 16 times 3 is 48. Alright, so y equals the square root of 16x minus 3. We know what the square root of 16 is, so we can rewrite that square root of 16, square root of x minus 3, square root of 16 is 4, so we have 4 square root x minus 3. The reason this helps us is because this is a vertical stretch, and this is a horizontal shift to the right 3 units. Okay? Alright, so let's just type that in. And remember, you don't have to get them all right. Okay? Just participate, because there's a lot of places to make mistakes when typing math, and I'll give you credit. Okay? Alright. And then, as we chatted, stretch horizontal to the right. No, 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 no. There's only one that goes 3 to the right. Boom. Cool. Alright, same idea, just for fun. Let's look at the last one. Okay, all we're doing is we're going to type it into a calculator. If you don't have a fancy calculator, go to the graphing calculator. Okay, and in the graphing calculator we need to type in 1.5. I'm going to factor 3 halves to 1.5, x plus 2. So let's go SQRT of x, that's our parent function, and 1.5 SQRT x plus 2. X plus 2, x plus 2 outside minus 4 delete, and there it is. Okay, so we're going to bring it back to down 4, stretch a little bit. Okay, so back, down, over, stretch, boom, boom, boom. The domain, it stops working right here. It stops working at domain, the x value, -2. So an inequality, how about all the x's greater than or equal to -2? Cool. And again, you could have hit help for that, where it shows you how to type in those in the range -4. From -4 up. So all the y's greater than or equal to -4. Okay? Alright. And similar question, we're done. Hit save. And I said I wanted to do 3 different assignments. So there was the first one. We don't need, let's go to solving a radical. Okay, how do we solve a squared or a square root? What's the opposite of squared? Square root. What's the opposite of square root? To square. Okay, so on this one, let's just grab a new piece of paper here. Heads in the way. Okay, so square root 2y plus 6 minus 5 equals 1. Okay, now the idea is reverse PEMDAS. Okay, and what I mean by that is PEMDAS. We add and subtract first. So I'm going to draw my little fence. And the opposite of a negative is a positive. I'm going to add 5 to both sides. Okay. Now I have the square root part is equal to a +4. Now I win. Now I can get rid of a square root by squaring both sides. Okay? The square root of something squared is itself So that all went away, leaving us with 2y plus 6 equals 4 squared, which is 16. Now just subtract 6. Divide by 2. And we win. So we're going to go right here. Now watch what happens when I type in a 5. To solve the radical equation on both sides, resulting in checking the, So now if I have a 5, could this be plus or minus when I took the square root of this? Let's just check that out. Let's just check right here. When I took 2y plus 6 equals, check for extraneous solutions. If I put a negative 5 in here, if negative 5, 2 times negative 5 plus 6, negative 10 plus 6, that's negative 4. Negative 4? Do we know how to do the square root of a negative? Simplify your answer. Use a comma to separate the answers. Check for extraneous solutions. Now I'm going to go 5, comma, negative 5. And I'm not happy. So what happened here? The correct answer was 15. Correct answer is 15. So now we go back and we're struggling, aren't we? So I added 5 to both sides, and what did I do wrong? Does anybody see it? Right there. 6. Poopy. Poopy. So you see how easy it is to make a mistake? Don't be like Monty. Okay? Alright, so let's get rid of this and get rid of this. And we're going to put a 6 here. Now when we square both sides, we get 36. We continue our line down. Subtract 6. 2y equals 30. Divide by 2, divide by 2, and y is 15. So, did I do it on purpose? No. Simple math error. Boom. Missed it. You can hit similar or just go to the next problem. Okay? Don't stress. You did a lot of work. Okay? Same idea here. Cube root, right? We're going to take the cube root of both sides. All right. And for those of you wondering what's he talking about, let's just whip this out real quick. All right. So now the cube root of 2x minus 49 minus 3 equals 0. Draw your fence. Add 3. Add 3. Cube root 2x minus 49 equals 3. Okay. To get rid of the 3, we're going to cube root. We're going to take the cube root. We're going to raise both sides to the third power. Okay? So just like a square root, cube root, those go away. 3 times 3 times 3 is 9 times 3 is 27. So 2x minus 49 equals 27. Plus 49 plus 49. 2x equals 76. Divide by 2. Divide by 2. X is 38. Keep your fingers crossed. Yes. All right. So that's what we're doing for next week. Okay. So We're just going to hit save. Take one long session, 2 short sessions. For those of you pushing yourself, try the review problems. After spring break, we'll come back and we're going to move on to exponential functions, growth and decay, which is an important topic because of COVID-19. We saw how it grew, right? Okay. Now, I mentioned in the video that it looked like some of you, not all, but some of you actually have done Mathia. If you don't like using Math Excel, remember you can go to your Clever account, scroll down to Math, and find your Carnegie Learning Math. Okay, so go ahead and click on that. And when you're there, this is Algebra 2. If you look for your Algebra 2 class, click on Mathia. I've got it coded so we're doing the exact same material. And I did that poorly. My bad. This is Algebra 2. So we're going to go to the Algebra 2 class. There we go. Alright, so Algebra 2. We are inverting functions, right? And very first one, inverting functions. Click on Let's Go. I've got you all coded so you're right where we're at. Click Let's Go. This counts as practice. If you would rather work in Mathia, more power to you. It's not better. It's not worse. It just talks a different language, okay? So we have the same kind of concepts, and you don't have to do all the work. You just have to participate. All right, inverse functions. Now, this attacks what we're studying in a different way. It talks different. So when you invert a function, all the y's become x's, all the x's become a y. Okay? Little video here.
So the inverse of the point at -1, 2 is 2, -1. Let's throw a few more points and their inverses on the coordinate plane.
So they're flipping them. Flipping the x and the y. The y becomes an x, the x becomes a y.
One thing you may notice is that each point and its inverse are reflections across this line, the line described by the equation y equals x. When the graph of a function is reflected across the line y equals x, we see the graph of the inverse of the function. For example, we can graph the inverse of the function f of x equals x squared by reflecting the graph across the line y equals x. Is the inverse also a function? Or we can graph the inverse of the exponential function f of x equals 2 to the x. Is this inverse a function?
Yes. Okay, so you come on over here to determine the inverse of a function. We flip, make the coordinate point negative, make the coordinates the point negative, reverse. You flip them, okay? So literally just go shift, parenthesis, -1, 2, enter. Parentheses, -2, 4, enter. Parentheses, 1, 1, enter. And, forgot my negative. Given any point, if a point has a same x and y, both coordinates are negative, boom, okay? And the inverse of y equals is not a function, and 2 to the x is a function, and you move on, okay? If Mathia is more your thing, go for it, okay? Now, one of the things about Mathia, don't feel bad, it's just like if you miss it, I'm going to give you credit for it. It's okay to click on hints, and here's an example. Sketch the graph of the inverse function, right? And you got this, and you're going to go through it, and you're going to practice it, and then you come on over here, and you go, select the graph that is the inverse of this. Now, when you do the inverse here, okay, you swap. Y equals 7x plus 6 swap. That goes there, that goes there. X equals 7y plus 6. Draw a little line, minus 6 minus 6. X minus y, x minus 6 equals 7y. Divide by 7, divide by 7, divide by 7. Y is equal to, we factor out the 1 over 7, getting x minus 6. So the answer is over here, right? And you click and it doesn't count it. And you click and it doesn't count it. And you click and it doesn't count it. What they want you to do is click on this line here. How did you know, right? So you got to, Mathia, there's some little idiosyncrasies you got to overcome, okay? So describe the relationship. It is a function. Describe the relationship. It is a function, and it is invertible. We can have an inverse because they are both functions, okay? All right, I just wanted to show you that Mathia is an option for those of you that like it, because I saw several of you had done Mathia in the past. If MathXL is not your thing, I love Mathia because of the hints, the solver tool. At the same time, there's a learning curve to any of these. Have a great week, everybody. I want you to have a great spring break. Let me know how I can help you, but you're not expected to work over spring break. Bye-bye.